Okay, so for this next video, what we're going to talk about is how we can use information that we know in order to find the rest of zeros. Because we run into some issues. If we can factor, or we can use the quadratic formula, that's great, and we're going to be able to find all of our zeros. But if you take a look at the expression that I have in this example, x cubed minus 28x plus 15, that problem we cannot factor, right? We don't know how to factor that a cubic trinomial. We also can't use something like the quadratic formula on this problem, so we're kind of stuck with this one. But the fact that they gave me an answer, x is equal to 5, that is going to be the key that I need in order to find all of the rest of the zeros, which is what they're asking for, right? So we're going to find all of the zeros of f of x, and if you notice, we should have 3 of them. They gave us 1, which means it's our responsibility to find the other 2, right? So let's see how we can do this. In essence, what we're saying is, when they tell us that x equals 5 is a solution, was that there was some kind of an equation, okay, something equals 5, right? And in this case, we've seen some of these problems already, that something is really x minus 5 is equal to 0 to get that x is equal to 5, right? So we have to kind of work backwards a little bit and take our x is equal to 5, right, and turn it into a 0 problem. We don't want it to be equal to 5. They want us to find it when it's equal to 0. So I just subtracted the 5 over, and I get this expression x minus 5 equals 0. Here's what we know. That means that x minus 5 is a factor. We're kind of saying x minus 5 times something is equal to x cubed minus 28x plus 15. Okay, so what we're going to do is work backwards. We're going to say if I want to know what that something is, I can divide by x minus 5, right? If I divide by x minus 5 and to find out what that something is, okay, I just have to do what we know how to do about division problems. This is a synthetic division problem. X minus 5 is a nice simple linear expression, so I'm going to set up a synthetic division problem. So I'm going to put the 5 on the outside. Remember, we're finding out what makes the divisor equal 0, in this case 5, okay, and I'm going to set up my synthetic division symbol. I'm going to be careful. I'm missing x squared in my numerator, so I'm going to put a 0 for the x squareds, negative 28, okay, and 15. Okay, so after I do this division, let's do that. Okay, I get 1, 5, add down the column and get a 5, multiply and get a 25. Okay, 25. Let's fix that. Okay, I'm moving too fast. Okay, I have a 25 here. Add down the column, I get a negative 3. Multiply one last time, I get negative 15. When I add down the last column, the remainder is 0. Okay, so I'm going to say x squared plus 5x minus 3, no remainder. This is my second factor. So the thing that I was missing here is x squared plus 5x minus 3. So what I'm saying is x minus 5 equals 0. That's one of my factors. This expression I can try to factor, but in this case it doesn't work, right? If I try to find what multiplies to negative 3 that adds up to 5, we can't find anything. So in this case, I'm going to say, all right, this is my other factor, set it equal to 0, and this looks like another quadratic formula problem. So I'm going to say negative 5 plus or minus. I'm going to come off to the side to find out my discriminant, what goes underneath the radical, and that would be 5 squared minus 4 times 1 times negative 3. That looks like 25 plus 12, which is 37. Okay, and it's all over 2a in the quadratic formula. Our a is 1, so it's just 2. Okay, so I'm going to say this is my answer. This is going to give me 2 solutions, right? Let's go to the calculator. This is asking us to round to the nearest 10th if necessary. Well, in this case, it is necessary. So we're going to actually take the square root of 37. The square root of 37 in this case is about 6.1. Okay, so it's 6.08, which we're rounding to the nearest 10th, so we'll say 6.1. So I can turn this into negative 5 plus 6.1 over 2, and the other one is negative 5 minus 6.1 over 2. Okay, so if we do the negative 5 plus 6.1, I get about 1.1 over 2, rounded to the nearest 10th is 0.5. Okay, when I do that to the other one, I get negative 11.1 over 2, which is about a negative 5.5, a little bit less. Okay, negative 5.5. Okay, so you can do that simplification on your own, but I get these 2 answers. So here's the big summary of the problem. Okay, they're basically saying if the highest exponent is 3, that we should be able to find 3 zeros to this problem. They gave us one of them. So this is our first one as x is equal to 5. Okay, we just divided away the factor that produces x equals 5, right? And we figured out that the remaining expression after that's divided away is x squared plus 5x minus 3. Your job is to then do whatever you need to do to solve that. Since this was not solvable by factoring, we used the quadratic formula. The quadratic formula gave us the other two zeros. X equals 0.5 is 1. X equals negative 5.5 is the second one. So 1, 2, plus the one that they gave us up here. Those are your three zeros. Okay, so we need to use everything we know about solving and dividing when we run into problems like this where factoring is not an option. Okay, so we couldn't factor at the beginning, and we also couldn't factor after we figured out what our remaining factor was when we divided away x minus 5.